In this video, we're going to take a look at the 3 sample applications that come with the Microsoft .NET interface for LEGO Mindstorms. Each of these applications makes use of the Roverbot configuration from the Constructopedia. These applications include a music sample, a remote control sample, and the Roverbot sample. Each of the applications is available in Visual Basic, C#, C++ CLI, and J# as part of the SDK. We'll be showing the code here in Visual Basic. The music sample provides an emulation piano that can be used to play notes on the RCX. For example, when the low C note on the RCX piano application is pressed, it plays a low C on the RCX device. At the same time, a high C note will play its respective note on the device. For you piano purists out there, we've gone ahead and mapped the QWERTY row of keys to a middle A and up, and the number row above it to its respective sharp and flat notes as well. This makes it easier for you to replicate your favorite 1980s TV moments, such as, or, for you video game enthusiasts out there, some of the moments from your favorite 1980s video games. And so on.
Now let's take a look at the code that went into creating the music sample. As you can see here, the application is simply a form that has a piano painted on it. This piano is a user control that raises an event, with piano key pressed event args as part of it. Those event args include information about which key was actually pressed. If we take a look at the code that goes into the form, you'll notice that we have an instance of the RCX class. That class is instantiated inside the constructor and connected via USB. If we wanted to, this would be the location where we would change the connection from USB to RS-232 for a serial port. Finally, the only other Mindstorm-specific part of this application is where we handle the event of the piano key being pressed. When that piano key is pressed, we call a utility method to convert the enumerated type into a specific frequency, and then we call playTone on the RCX object with the frequency and the duration. The frequency being the hertz count, and the duration being the number of tenths of a second, as used by the Mindstorm natively. This is all the code that's required in order to create the piano application, with the exception of the user control UI.
The remote control sample controls the RCX remotely from a Windows application. In this scenario, we're going to use the RCX in order to maneuver a cup through an obstacle course. As you can see, we're going to start off at one end and be responsible for maneuvering the cup all the way to the other end of the obstacle course. Now this is being controlled entirely from the desktop right now, and the RCX is just merely following the commands it's given by its apparently drunk controller. As the cup gets moved through, you'll notice that when necessary, the RCX has enough horsepower to manipulate the course of the track itself in order to get its job done. It's not recommended for production, but in this particular case it works well enough. So as you can see, whether by brute force or by skill, we're able to get the cup from one end of the obstacle course to the other, entirely controlled by the desktop application.
Now let's take a look at the code that goes into making the RCX remote control sample happen. Here we've got the solution open inside Visual Studio, and you'll notice that the form is simply a window that has 8 different arrows in it. Each of these arrows represents a combination of the up, down, left, and right keys that can be pressed. If we dive into the code, you'll notice that the first thing we have here is an instance of an RCX class as part of the form itself. Another thing we have here is we have a constant variable of RCX power that indicates how quickly we want the RCX to move whenever a key is pressed. 8 is actually the highest you can have for an RCX, so we just set that as being a value here. However, if we were using a different configuration with a faster or slower speed, we would change to that. Now we wanted to have a very responsive application, so rather than just handling the up and down keys for each particular direction directly, what we do is we track the state of any given key and then update the RCX on a timer separately. So you notice in the key down and the key up, we merely track whether a key has been pressed or released. And then finally in the timer tick, we walk through and we see which combination of keys have been pressed. So for example, if the up key is pressed and the left key has been pressed, and they're both being held down, then we tell the motor to stop on the left side and to move full speed ahead on the right side, so the way it moves forward and left. We also turn on the up left picture box so the way that particular picture box can be shown. As the application runs, different arrows will be shown depending on the arrow configuration pressed by the user on the desktop, and the RCX will track that. This is all the code that goes into making this application happen. Some of it's very repetitive, but you'll notice how simple it is in order to tell the power of motor A to be 0 and the power of motor C to be the full speed ahead.
The RoverBot sample provides an example application that controls the RCX entirely on its own. This application has been designed to take into account touch sensors so that it can maneuver around obstacles. We're going to start the RCX at one end of this course and see if it's able to make it through all on its own. When we launch the sample application, you'll notice the RCX moves forward and it hits a wall, and as it continues to hit walls, it will receive those touch sensors and maneuver around those accordingly. Notice that when it comes in contact with a wall, it will actually back up a little bit until it's able to find that the touch sensor has been let go. And occasionally it gets a little out of hand. And it turns out in our particular scenario, the RoverBot has decided it would rather go home than complete the course. So we'll give him a little bit of help here. Send him back in. Come on now. Quitters never win. As you can see, the second time through the course, we seem to be having a little bit better luck. The application moves forward. Writing secure code, of course, always a tough topic. And the RCX has decided to leave the course altogether.
Now let's take a look at the code that makes the RoverBot work. In this application, we have an instance of the RCX class. That RCX class gets instantiated inside the run method, and two of its sensors are set up to be touch sensors, the left and right, or 1 and 3 sensors respectively. Both of those sensors are set up to also use event handlers inside our code. When those event handlers are triggered, they call the update movement method. Inside the update movement method, we're responsible for taking a look at the current state of the sensors and reacting to that by changing the motor's directions and speeds. For example, if the left sensor has been pressed, we want to turn the left motor on full speed ahead and the right motor on full speed behind. That will help us to turn right. However, if it's not pressed, but the right sensor is pressed, we want to do the opposite and turn left. If neither sensor has been pressed, we're going to move forward full speed ahead. As a result, we're able to build something that is able to navigate around simple obstacles. Now, of course, this wouldn't be ideal for navigating through a map, but for the purposes of a simple application, this does everything we need.